Dear students, today we will discuss about declarative paradigm. So remember this figure where we have classified all of the paradigms available to us. So we have functional, object-oriented, imperative and declarative. So we have discussed imperative last time, and today we will be discussing the declarative paradigm, which has SQL, Prolog, GPSS and similar languages. So what is a declarative paradigm? It asks a programmer to describe the problem to be solved rather than an algorithm to be followed. So actually the algorithm is already known and is already established. So the programmer just configures some of the things and get the results. So applies a pre-established general purpose problem solving algorithm to solve problems presented to it. So what would be the task of a programmer in such a scenario? That it is developing a precise statement of the problem rather than of describing an algorithm for solving the problem. So the programmer is only focused on the precise statements, and you will be learning some of such precise statements in some of the modules when we will be discussing databases and SQL. So what is the obstacle we have in declarative paradigm? Knowing the generic algorithm and then implementing it. So first of all, we should know what is the algorithm that will be used for such type of problem. And there could not be an algorithm that can solve all of the problems of the world. So we need, or we can only implement this kind of declarative paradigm for some special purpose softwares like political, economic and environmental, etc. So we normally cannot generalize until now. However, we will discuss in the next slides that how the logic programming and inventions in the mathematics have led us to make somehow the generic algorithm. But the main obstacle at the moment is that we need to know that particular algorithm, and then we should implement, and then whatever the problem is found, we need to write, or the programmer need to write the precise statements that can activate that algorithm to solve the problem at hand. So for example, weather forecasting is one of the example of declarative paradigm. So the programmer need not to invent the weather forecasting algorithm. The algorithm is already known, that has been built after a rigorous and critical research, and the programmer now need to enter the current data of weather conditions. What is the pressure, air pressure, what is the moisture level, humidity, etc. So all of such parameters will be given to this algorithm. So we were discussing about logic programming, that it has given a boost to the declarative paradigm with a discovery that the subject of formal logic within mathematics provides a simple problem-solving algorithm suitable for use in a general purpose declarative programming systems. And that has emerged as a logic programming, which you will be learning in some of your course. So if we summarize today's module, we have digged into the declarative paradigm and what is the task of a programmer, what are the obstacles, and how logic programming is giving an edge and boost to the declarative paradigm.